Thank you for joining me on my learning journey. Today I'm going to be sharing my learnings on how to solve problem 21 from the AMC 2019 question paper. So what is the area of the triangle formed by the lines y equals 5, y equals 1, plus x, and y is equal to 1 minus x? So I encourage you to go ahead and try this problem on your own and pause the video before coming back and hitting play for the explanation. So I'm assuming you've given this problem a go. Let's start solving it. So the way I would approach this is I would try to, of course, find the base and the height to determine the area of the triangle. But the way I would do that is trying to find the points of intersection. So here's what I'm talking about. So let's say we have a triangle right here. And we're trying to find the base, which is this line here, times the height. We're trying to find these two values. And so how do we do that? The way I would do it is by finding what this point is, and this point is, and this point is. That way we can actually find the distances, because right now we're not given distances. But what we are given is these equations, and how can we find these equations, find the intersections of these equations? Well, that would be the solutions to the system of equations. So I'm going to try and find the solutions to the system of equations for each of these. And you can see that for each one of these sides, it intersects the two other sides. So this and this will be one system. This and this would be one system, and these two sides would be one system. I'm gonna move this yellow dot. I'm gonna move the yellow dot on the other side, right here. Ah, it's not yellow. Okay. There we go. So what I'm going to do is I'm going to write these out as systems of equations, and I'm going to start with the yellow one. So let's say y is equal to 5 and y is equal to 1 plus x. So using substitution, they've already told us that y is equal to 5, meaning we can substitute it in here. So 5 is equal to 1 plus x. Subtract 1 from both sides and you get x is equal to 4. And because they already tell us that y is equal to 5, the point where these two intersect, if this is, I'm going to label these actually, y is equal to 5. I'm going to make this one y equals 1 plus x. And this one, y is equal to 1 minus x. So if they're saying that this line here intersects this line here, the y point has to be 5, and 4 is the x coordinate. So we have our first coordinate for where they intersect. So for these two lines, I'm going to do it in pink. 1 minus x, y is equal to 1 minus x, and y is equal to 1 plus x. So when I'm looking at this, what I'm going to do is elimination, because we have positive x and negative x. So if we were to add these two equations right now, the x would cancel out. So we would have 2y is equal to 2, meaning y is equal to 1. And so we can plug that back into the equation. So 1 is equal to 1 minus x, subtract 1 from both sides, and x is equal to 0. So we have our next point. We have 0, 1. And for this last point, we have y is equal to 5 and y is equal to 1 minus x. So here again we can substitute. Subtract 1 from both sides. 4 is equal to negative x, or negative 4 is equal to x. So our next point would be negative 4, 5. So how do we find our distances from this? Well, we know right away that since these two have the same y coordinate, it's going to form a horizontal line, like this one right here. And we know that we're looking for the line perpendicular to this that includes this point here. So we're looking for a point perpendicular to y is equal to 5 because that's the line that these 2 points sit on, and includes the point 0, 1. So just to visualize this a little bit, I'm going to graph it here, and I realize I haven't drawn my x and y axes, or however you say. Is it axes? I think it might be axes. Okay, so we go here, and I'm just going to go -4, 1, 2, 3, 4, 1, 2, 3, 4, 5. And then we've got this one here. I'm going to do it in the same colors. Okay. And then we have 0, 1. We can see that right away, 0, 1 is on the y-axis. And so this makes our job of finding the distance even easier, right? Because we can see that it is right on the y-axis. And here, what we can do is, we know that since this is a horizontal line, we're not going to have any, we don't even really have to use distance formula. We just know that it goes up by 0 units and to the right or to the left by 8. So we know that this distance here is 8. So in our A is equal to half BH, we already know that our base is equal to 8. And we can also see here that this distance here is 1, 2, 3, 4. It is 4. And so how would we know this if we weren't graphing it? Well, we would know that it's perpendicular to y is equal to 5, and that it includes this point right here. And so that line would have to be x is equal to 0. And we know that it bisects this line. And because we know that the point where these two will intersect will be 0, 5. And we know that because it's on the y-axis, it'll be like that. And so we know that the distance must be 4. And we can check it with our graph here, and we know that the distance is 4. And so now that we know half, and we know the base and the height, and we can multiply that by half. Oops. Okay, so it'll be 8 times 4 divided by 2, which we know would be 16. And so on our test, we would circle E. So that's it for this learning. Thank you for joining me. I'll really appreciate it if you leave your comments, feedback, and further suggestions for additional learnings below. I'll see you in the next video.